Okay, good morning to all of you. Sorry for the delayed beginning. Today's resource person is Ashwin Rao. He's going to continue the discussion on discrete mathematics as part of our 40-week GATE 2027 presentation preparation. Thank you, Ashwin, for taking your time off on a Sunday to share your valuable, knowledge. Over to you.
Sure, sir. Thank you, sir. Good morning, everyone. Today I am presenting revision handbook on. Today I am presenting discrete mathematics CS grade CS revision. This presentation mainly focused on three important areas, mainly monoid, graph, theory, and combinant network, which contains algebraic structures, graph theory, and combinatorics are main concepts. As today we discuss. So algebraic structures are the algebraic structures covers semigroups, monoids, groups, and abelian groups. Graph theory covers trees, coloring, matching, planar graphs, and user concepts. And combinatorics includes counting techniques, recurrence relations, and generating concepts. PYP focus on solution, discussing exam patterns, shortcuts, and common mistakes. So, what is an algebraic structure? A binary algebraic structure in that it contains various building blocks of abstract algebra, mainly binary operation, which combines two elements of a set. The important properties are closure, associativity, identity, and inverse. If you have heard of the previous session, you can understand these properties closure. If A, comma B belongs to S, then A star B belongs to S. This result states S. S means set. Associative means A star B into star C equal to A star B star C. Grouping doesn't matter when both results is the same in associative. Identity element is each element for belongs to set S, then A star E equal to E star A equal to A for all A belongs to S. Inverse inverse element for each A belongs to S and B belongs to S such that A star B and element B star belongs to S such that A star B equal to B star A equal to identity element E. This is the algebraic hierarchy concept. Mainly first comes in semi-group closure plus association. Example: set of n of positive set of positive numbers in natural number, and then monoid there. For semi-group, it adds identity element. Example: set of n x, comma x, which is where x represents each element in the natural number. Group adds for monoid, it's inverse of every element. In example, z, comma plus z, comma addition, which corresponds to positive integers. Abelian group plus commutativity A star B equal to B star A, which represents R for every zero every null element x comma x. It adds group plus commutativity. Next comes monoid and versus group. The key difference. Although these groups and monoids are similar, but there are some properties which make them different from each other. Mainly, it's different in inverse law. It's not when group group follows the inverse law, but the monads usually don't follow that law in general. Only difference is group require an inverse for every element. This is the example in modular arithmetic. You can see that abelian group, this is abelian group, this is also group. This last containing set also group if and only if n is prime. And the condition you can refer. This is the gate value. So here C is the answer because Y is followed. Which of the following is said as group? If you go through all these conditions, all the conditions of group, you can easily spot that set of Z of positive integers follows closure property, associativity, identity properties follow, inverse also follows. Whereas all the other conditions also mentioned. Why? Because to avoid the confusion. Answer is C. Common mistake is not checking inverse existence for every element. You should check every property to satisfy a group or a monoid or semi-group condition which will be asked in gate question. The shortcut methods, common mistakes that students follow, which should be avoided. The shortcut is if not associated, cannot be group. For yeah, every n element of set positive n, identity always zero. It remains zero. Element k of n under mod n multiplication group if and only of n is prime. This kn under mod n multiplication it follows group if and only if n is prime it follows. So every group is a monoid, but not every monoid is a group. Why? Because monoid does not follow inverse. That's why every group is monoid, but not every monoid is group. Common mistakes include confusing monoid and group. You should say that every group is a monoid, but not every monoid is group. You should remember inverse part and map all the closure associated laws, identity laws to the group or monoid. Just to confirm what is group, what is monoid. Assuming commutativity, always verify. Forgetting zero has no multiplicative inverse in a set of Q or set of R. You should not forget that. And treating natural number of positive set of positive natural numbers as a group. No negative numbers in n. You should not treat it as group because there is only positive element. Because of that, it does not follow any negative element. So that's why you should not treat that as group. Moving on to graph theory. Graph is G is equal to vertices vertices comma edges. As you can see here the notation you can explain. Edge E connecting them. There are different types of graph also. Directed graph where edges have direction, edge represented as ordered phase U comma V. Undirected graph where edges are unordered phase U comma V, direction irrelevant. The degree of graph is the number of edges incident to vertex V in the graph. Handshaking theorem where for summation of degree equal to 2 modular E. Sum of degrees is always even. Next, moving on to connectivity, there is a properties like walk, cycle, trail, connected graph, and path. The walk represents sequence of vertices edges where both may repeat length equal to where both may repeat, which corresponds to length equal to number of edges. Trail is a walk where no edge repeats, vertices may repeat. Cycle is a closed path, starts and ends at the same vertex, all other vertices distinct. connected graph represents a path, every path between every pair of vertices. If not, graph has connected components. The path is walk with all distinct vertices and therefore distinct edges also. These are the trees and spanning trees. These are the condition what you represent here. Like here in here you sorry in here you say that the edges is tree and this is the unique path and this is the no cycles minimum connectivity. The three properties are definitions as you can see here. Tree is connected. Tree is a connected acyclic and undirected graph. There will be no undirected cycles. A forest is a disjoint union of trees, may be disconnected. A rooted tree has a designated root vertex at the top of the hierarchy. A spanning tree of graph G, a subgraph that is a tree that includes all vertices. A graph G may be have multiple spanning trees. Minimum spanning tree minimizes the edge weight. You should also remember all these properties. Next, moving on to biparate graphs matching.
Hello, Ashwin.
Am I audible, sir?
Yeah, there was a break. Could not hear.
Yeah.
Can you repeat last
Yeah,
sentence?
yeah, sure. The tree properties are like a tree is a connected acyclic undirected graph where cycle means if you connect if you consider 3 points A, B, C, there should not be any cycles like a triangular cycle or any type of cycle. It should not be. It should not be there. If it is there, it doesn't call as trees. And for moving on to a forest, it's a disjoint union of trees may be disconnected because the independent tree is connected to the same node which we call as forest. A rooted tree has a designated root vertex at the top of the hierarchy. Like if forest is contained root tree. Forest is collection of trees. They may not be disconnected. Like if you consider elements of the number which is only divisible by 2, the numbers which are only divisible by 3, which connected each other with the number 3 at the top position, you can mainly 3 to 4 trees like that you can consider as forest. Then comes the rooted tree. It has a designated root vertex at the top of the hierarchy and spanning tree of the graph. A subgraph that is a tree and includes all vertices. A graph G may have multiple spanning trees. Minimum spanning tree minimizes the edge weights. The minimum spanning tree that contains that edges will more useful for reducing the calculation speed. Moving on to biparate graphs and matching. Biparate graph, vertices split into disjoint sets of U and V, and every edge connects a vertex in a U to one in V. There is a condition that graph contains no odd length cycles. The test is true colorable using BFS or DFS. Here BFS is breadth first search and DFS is depth first search. Its notation noted as K m comma n equal to complete biparate graph. Whereas matching a set m of edges with no shared vertices. Perfect matching is every vertex is exactly one edge of m. Maximum matching, large possible set m. This Cohen's theorem. In biparate, max matching equal to minimum vertex cover. There is a max matching will be there. the minimum vertex coverages will be minimum. Hall's theorem is condition for perfect matching existence.
Ashwin,
I will.
Ashwin, to make this interesting, it will be nice if you can give us some real world examples of some of these concepts, okay, from next time onwards. Okay.
Okay. I will. In
Yeah,
previous
because
notes, I will
otherwise
share.
we will not be able to relate to why this is required. Okay.
Okay.
Wherever
Yes,
possible.
because
Okay.
I, this is required for solving problems. I will share pattern to solve. Also, I will share the relevant examples also.
Okay.
The graph coloring you can see here. The four color theorem. Every planar graph can be colored with almost four colors, at the most four colors. And the applications are scheduling, register allocation in compilers, and frequency assignment. The planar graph and Euler graph, and then here the gate PYQs. What is the chromatic number of a complete graph TN? This diagram I will include in notes also, because in presentation I will include that explanation. These are the common gate question. These are gate shortcuts you need to remember. Combinator. Next, moving on to combinatorics. Combinatorics is in EU level questions we have encountered permutation combinations and all, which will be repeated for gates, which is the most important one. Permutations, as you can see here in formulas and explanation also. Please remember that it is required to solve the upcoming problems also. This is the inclusion and exclusion principle that from the previous session. Then comes pigeonhole principle and recurrence relation. What is this pigeonhole principle? If n of elements connects to m containers and n is greater than m, at least one container holds greater than or equal to two items. Examples are: among 13 people, 2 share the same birth month. Among n plus 1 integers, 2 are congruent mod n. In a group of, then example, another example is, in a group of 5 points in 2 cross 2 square, 2 are within square root 2 distance. Then comes the recurrence relations, where this is the Fibonacci formula, this is the Tower of Hanoi formula, and this is the linear homogeneous formula, which is characteristic equation method.
Sorry,
How
go
to
back.
solve it?
Sorry, go back. What method you said? Characteristic equation method. Huh? Okay.
Equation method.
Okay.
How to solve a linear recurrence relation? Please note it down. You can for this is the detailed explanatory, but in shortcut method you should require these formulas and all. And about this master theorem, divide and conquer. For this master theorem, about this master theorem, divide conquer is this the T of n. T of n equal to a t n bar b n slash b plus f of n, which C complexity section for cases. This is the gate BYQ. How many ways the letters in India can be arranged? This is the ways that can be arranged in. Gate PYQ. You can note it down, screenshot it for reference. This is the key formulas for revision.
Hello, Srisha.
Uh,
Welcome to you. We are on day 2, that is the second week. The topic is discrete mathematics, and the resource person is Ashwin Rao from 8th semester SME yeah, please stay here. Ashwin, go ahead, please.
yeah, then PYQ pattern analysis concludes how much question will be there in gate. 8 questions are always checked in 4 actions, and chromatic number are also there. This is the PYQ pattern. Please refer to this in the presentation. You can take screenshot also. Please screenshot also if you want. If the conceptual question, you can refer to it if you can't understand. I will share this all the slides, relevant materials in a notes, compiled notes. This is the revision set. Graph theory revision sheet, the combinatorics. Key takeaways are like understanding the hierarchy, semi-group, monoid, group, and abelian group. You should remember this formula. Remember this slide. How each group related to each other and how it is a hierarchy everywhere. And graph theory, this please master that handshaking theorem, Euler's formula, chromatic numbers and tree properties, which I will share in notes. And practice permutation with repetition, inclusion, exclusion, and recurrence. So if you take permutation for a permutation problem, if you take so much time, it will not be time productive or time manageable in it. And exam strategies: always verify all axioms. Watch for edge cases in for monoid group, semi group, and here concludes this session. Any questions? Any questions?
Yeah, since Srisha missed the first part, can you go back to slide 1 and quickly go through
Sure,
the first
sure,
10 slides? So if Srisha has any
sure,
questions,
sure, sure.
briefly explain and go ahead.
Yeah, this is mainly these are the concepts we covered, Srisha. Algebraic structures, graph theory, combinatorics, and previous year questions. This is the algebraic structure, as you can see here. This is the from previous session. This inverse element is new. This is the algebraic hierarchy. The semi this what you see here is mainly that group's exclusive property, how it is different from other. Like this is the hierarchy. Semi groups compass, then monoid, then group, then abelian group. Here are the relevant examples as you can see here. The Z is Z N R R. The R is real number. Z is a set of integers. N is set of natural numbers. Here, key difference I want to share you is groups require an inverse for every element, but monos don't require this difference. You should satisfy only closure associated with identity and inverse. These are the examples. You have PYQ, shortcut common mistakes. It's a graph theory. You should be thorough with that. I will share the previous year questions with sir. You can borrow it and just solve that. These are the just theory part. You should remember adjacency and the three properties, how it will affect the problems or how it will affect uh, concept understanding and all. This is the Euler's formula. V minus E plus F to 2. V means vertices, E means edges, F means I will share that explanation also. This and all the shortcuts, and you should remember all these formulas. Mainly Pigeonhole principles and recurrence relations also. You should solve this problem also. Mainly when I share the PYQs, you should solve that. You are able to remember each concept and practice it daily. A small succession, I mean small consistency.
Okay. Thank you very much, Ashwin, for your session. Thank you, Shisha, for attending. Please spread the word to other friends who are interested. They may be from our college or from any other college in India abroad. Okay. Thank you, Ashwin. We look forward to the next session next Sunday. Okay.
Sure,
So
sir. Sure,
till
sure.
we
Thank you.
find alternate faculty, Ashwin will be taking all the sessions as per the calendar which is announced. Wherever we have a better faculty who can do it better than Ashwin, then we would welcome such people to take the classes. Okay. The
Sure,
faculty
sir.
can
Sure, sure.
be students or people from the industry or our existing faculty from SME we would like to pay a honorary fees of rupees 100 to each of the faculty members